Okay, so good afternoon, all. Good evening. It's 4 p.m. Good evening, all. And today we are going to see the C++ program for doubly linked list. So here we have a sample template and use to implement doubly linked list in C++. So shall we start? Is the program visible to you? Okay, thank you. So let's start. We have these two header files, hash include iostream which is necessary for input output stream, which are we accept for display in C++. And then we have a namespace std is there for C in C out, and program for W. So after this title, we'll have a class now, which will be a DLL class. And then in this class, we'll have a data. This data it supports integer data. And then we have two pointers, which is DLL of type DLL. So it's pointer next for to travel forward, and then this is pointer previous, which will help us to travel backward. So either we can take this pointers and data inside a class, or we can have a structure node for this, and then we can use that structure inside the class. So now we are using this inside class only, and then we have a public section where we'll have the first function to create the head of the W linked list, and that is create DLL. This is our first function where we are going to create the head. So this head is initially going to be null, and when we create, we will pass it or return its address from the function. Hence, the return type will be DLL pointer. That's DLL pointer, create DLL. Okay, so this is how we'll create it. And then, or you can also have like this DLL node, which is a class name. And then here we have this DLL node, pointer next, DLL node, pointer previous, and then this DLL node pointer like this. Now we have we need a function to display this doubly linked list. So it's display DLL. And for this also we need this DLL node pointer. Okay. Because the linked list starts with head, right? So we need this head. Now we will end this class as we have two functions to create a doubly linked list and to display doubly linked list. And we have defined the data, which is in number format, and then we have this two pointers. One is next and one is previous. So now we will go ahead and we'll define these functions. First is DLL node pointer, and then we'll have this. So as this is the definition of the member function outside the class, so its return type is DLL node, and class name is DLL node, and scope resolution create. And after that, we have this a function to create the head node. For that, we will have this DLL node and pointer and that is a new node initially. Then we will allocate memory for new node using the new operator. That's new node equal to new, and memory sizes for a DLL node. So it's new DLL. This is how we allocate memory. So here we will say that this is to allocate memory for a node, for a node, or you can say for a new node. So we have allocated memory. Then what we will do? We will initialize this new node. So initialize this new node by data and address. So how we will initialize? See, we will ask user to enter the data for this node, new node. So enter a number, and then we will read it as cin, and then new node arrow date. So this is how we have initialized the data part. And how to initialize the next and previous? Initially they are initialized to none. So new node arrow next is equal to null, and new node arrow previous is also equal to null. So like this, the step 2 is over, which is initializing new node by data and address. And now we'll ask user that if the head is the address of the first node is equal to null, means there is no head exist. So the new node becomes head. So head is assigned a new address, and that is which is available in new node. So this is how we create head of the link. And now if the head is not null, so that is otherwise else, and we display the out that the head is already there. Head node is already there. Like okay. This is how we are creating this DLL. Only one node. We are creating only one node, that is the head. And then we return this head, because initially when we catch head inside of DLL pointer head as a parameter to the function, it was null. And when we are returning this head from the function, it has some address, and that is the address of the first node. So that is return head. So as we are going to return a pointer from the function, hence the return type of the function create DLL is nothing but DLL node point. You can see that is why we have taken this return type as DLL node pointer, as this function is going to return a pointer or address of type DLL node, right? So this is the create DLL function. Now second function is to display. So we'll take a display now from here. So copy the signature and then paste it here after create function, and then remove the semicolon, because this is not a declaration. Now we are going to define this function. Before starting with the definition, you should define, as we are defining the function outside the class, so it is should be defined using the class name as it is a member function. So return type is void, class name is DLL node, and then we have this display. So here we can see in the function we want to display the doubly link. So for that we need to travel from like node 1 to the node last. Currently we have only one node, but still display that node we need a temporary pointer, and for that we create this temporary pointer here, and that is DLL node pointer temp, as we have also seen in single linked list. So this pointer initially starts with the address of head. So head is the first node of the linked list. So it starts with the first node of the linked list, and while this what temp is not equal to null, means until temp has some address, go on is displaying the nodes. So while temp is not equal to null, like initially it has the address of head, then if we have further nodes, it may have the address of second node, third node, fourth node. So we display first node, then second node, then third node, and so on. And how we go ahead by copying the address of which is available in the next pointer. So in the first node, next pointer has the address of second node. In the second node, the next pointer has the address of third node, like that. So every time what we do, we display this. What we display, you can see here that we'll display this temp. So here in the body of the while, we display C out as it has the address of first node. So we'll display temp arrow data, temp arrow data, and then this temps next has the address of next node. So this temps next will be copied into temp, so that now temp will has the address of next node, like this. So when we reach to the last node, we'll have the address of null, because the last node next has a null value. Like currently we have node 1 only, head node, and its previous as well as next pointer has the null value. So we here, if we call this display function, we will be only able to display one node, because the doubly linked list has only one node. So this is it, and now we will go to the main function, and then we'll call these functions like create, DLL, and display. So this create DLL, then we have this display DLL. So this display DLL is here. Just copy this signature and paste it. So see, now initially we declared the functions inside a class, then we defined the functions outside the class, and now we are calling them inside some other function, that is main. But to call the member functions of the class, we need the object of that class. So how to create the object? Class name is DLL node. So class name is DLL node. Its object is D1, and then we will call these functions using D1. So initially we have D1 dot create. Similar D1 dot display. After that, here we'll give some comment like cout, and as we are calling this for create, we will write here calling create here, or we can say this is my create creating DLL, creating DLL or W. Copy it from here also, create W, creating W next, like this, and then semicolon, and then we have copied again, and then we'll say display, displaying W. So displaying W. Okay. So these are the two operations, creating and displaying. Now see whether we have passed the parameters necessary. So see, like we have created DLL node D1, we need to create DLL node pointer head, pointer head. Now this head is initially null, so we need to initialize this head as well. So here we will initialize it, head equal to null before calling create head or create DLL function. After this, when you are passing this head, which is a null, to the create DLL, so it is passed as an actual parameter. So capital H head with capital H is actual head, and it is cached inside this create DLL. See, this is a formal parameter, DLL pointer head. Actually, the class name is DLL node pointer head. So this small h head with small h is a formal parameter, and head with capital H is the actual parameter. So from the function calling function, we are passing actual parameter, and this definition receives that value inside a formal parameter. Now we have this, and this function returns the head again. So we need to catch it. So how we catch it? We catch it here as head equal to d1 dot create here. So see, initially we are passing the head to create DLL, which is a null value. Then it will create a new node, assign data, addresses like next and previous are null, and then we assign head equal to new node, and that head's address is returned from the create DLL, which is cached inside this head equal to this function. It is like this function is acting here like an expression, which is calculating something, assigning like allocating something memory, and that and memory is returned to the head. So we have allocated memory, we have stored the data, pointers are initialized to null, that new address is given to head, and that address is returned from the function. That is why the signature is head equal to d1 dot create DLL. So this d1 dot create DLL head acting as an expression which returns some value. That value is the address of first node of linked list, and that is head. And then we use this head here to display link. So like this. Again, we are passing the actual parameter to display here. Okay. Now we will try to run this code. Okay. There are in the create DLL. There is a mismatch of function name. So in the class here we have not used DLL. We have changed the class name from DLL to DLL node, and we have not mentioned it properly. After that, in the display function is proper, yeah, DLL node point. We'll run it again. Okay, now see it is running. So see, we have displayed the C++ program for doubly linked list. Then we are creating a doubly linked list, and then we have to enter a number. Suppose I entered a number 10. So I'm displaying the doubly linked list and I got 10, right? So this is how I display a doubly linked list, and the 10 is displayed. Okay, can you see that on your screen? 10. Can you see 10 displayed on your screen? Okay, yeah, thank you. Keep interacting in between so that you can understand whether it is audible, visible, or is understandable to you or not. So, see, we'll do now some little formatting, like after this message creating the W linked list, we are accepting that enter a number, and after that enter a number we display. So here we have just given a single slash in. So we'll give two slashes like this so that it will look properly. And then for enter a number, I will give a slash in and a slash here. So slash in and slash. And to display, when we display, we'll do some little formatting as we have done it in singly linked list also. So what was that formatting? We have mentioned head as a message here. So it was like head, and then it is pointing to the first node. After that, when we display the data, we display it like a block that is enclosed between some bars to indicate uh, a, a node. So we have indicated that node in this bar. And then after this, this next arrow, we also have a previous arrow. Why previous arrow? Because now it is a doubly linked list, so it should have two pointers, next pointer and previous pointer. Now we'll see how it will be displayed. We are running it again, and we again got some errors. So this operator is missing here. Let us see. Okay, so we have a first value 10. Okay, and see how it is displayed. So here is pointing to 10, and 10 has a previous pointer. 10 also has a next pointer. Okay, so then also have this slash in, and then we have 10. Okay. So creating a double linked list, we have a 10, and then we display it. So this is how we'll get the outputs. We can also uh, can separate them in our school, and now displaying the double linked list. So that is now done. Okay, so see, 10 is the first node. It has a previous pointer, it has a next pointer, and they are pointing to null. So we can also have like this, they are pointing to null. So can we show that they are pointing to null? Yes, we can do that by little formatting in the this display function. So here we can say out, and then it's not similarly. Can have it here also. That is done. Here is pointing to 10. 10 is the first node of the doubly linked list, and its previous pointer is pointing to null, and the next also is pointing to null. So this is how we have a single node in the list. So can we have more nodes? Yes, we can have more nodes, and for that we can use a insert function. So for that we can write a new function here. It is void insert nodes, and then DLL node pointer type. This is the declaration to insert the new nodes in the function, sorry, in the doubly linked list. Copy the signature of this function, and then we'll write it here like this. Void insert nodes, DLL node pointer head, and then the body of the function. Function is defined outside the class, so it is defined return type, class name, scope resolution, function name, like this, and formal parameter. So as I want to insert new nodes, so again I have to do the same thing. That is DLL node, pointer, new node, and again those three steps I have to do. So which are those three steps? Allocate memory and all. So here I can do that by copying from this function. So like this, and copy it. Then I'll press allocate memory, enter a number, new node, and then we'll have this new node, and then I can insert. So to insert, every time we are going to append new nodes. Like after 10, there is 20, there will be 30, like that. So for that, I need to reach at the end of the linked list every time. So for that, to reach at the end of the linked list, I need a temporary pointer. So which can travel from head node to the last node. So that is temp. And I use this temp to reach to the last node of the linked list, starting from the head. So temp equal to head, and after that, while I'm not reaching to the last node whose next is null, the temp arrow next is not equal to null. Until the temp's next is not equal to null, go to the next nodes. So for that, temp will always keep switching from temp to temp's next. So it will always copy the address of next node from the current node, and it will keep switching to the next node until we get the node having next as null value. So then this is how we reach to the last node. So to append, you can mention in the comment, to append node, go to the or reach to the last node, reach to the node. Okay, so after reaching to the last node, we can simply attach new node like temp's next, temp arrow next is equal to new node, and after that, new node arrow previous is temp, new node arrow previous is equal to temp. Why? Because there are 2 pointers. If we are appending a new node, so the last node's next is new node, and new node's previous is the last node. So the new node now becomes the last node. Like so this is how we are appending. And Now we'll copy this signature of insert nodes and then we'll go here the main function, and in the main function we will call it insert new nodes. So this formal parameter will be replaced by actual parameter, and like we have here one creating doubly linked list, then we have second that is displaying doubly linked list. Similarly, we will have third, and that is inserting new nodes. So insert new nodes in doubly. Third operation, insert new nodes in doubly. Insert new nodes in doubly. Okay, so this is how I will insert. Now to call this function, I need an object that is d1 dot insert nodes, right? So d1 dot insert nodes, and here it's starting from head, reach to the last node, and then insert new node like this. So this is what we are doing. And then we will check whether we will be able to insert it or not by running the program. So okay, sorry. After insertion, we have to display also, right? We have to display the link. So in one insert node function, we are inserting only one node. So if we want to insert two nodes, so we have to repeat it again. So after one node insertion, we'll display it. Again, we'll insert one more node and again display. So that is it. Right. So in the insert node function, we have said enter a number. So let us run. Temp equal to head, line number 64. I just said, oh, temp is here is a pointer. So temp should also be pointer. Perfect. Okay, now we have this. So enter a number. Now it's 10. So see, the linked list with node 10 is displayed. Now we have third operation, insert new node. So I will say 20 and see 20 is also there. So 10 previous pointer is pointing to null, 10's next is pointing to 20. 20's previous has the address of 10 and 20's next has the address of null. So as there is no node after 20, so its next has address null. When there was no node after 10, 10's next was null. But now 10's next has the address of 20, as 20 is inserted as a new node. Now when we insert third node, that is 30, 20's next will have the address of 30, and 30's previous will be 20, and 30's next will be null, right? So I'm entering a value for a new number, new node, that is 30. And you can see we have this here. So first node is 10, its previous is null, next is pointing to 20, 20's previous is pointing to 10. That means 20 has the previous address of 10, 20 has next address of 30, 30 has previous address of 20, and next address of null. So this is how we create a doubly linked list. We display doubly linked list, and we can insert new nodes in doubly. Have you understood this? If you have any doubts, you can ask. Now this is about doubly linked list. So we can also make this doubly linked list as a circular link. Okay. So how to make this doubly linked list circular? That will we'll see now. Okay. So how to make this doubly linked list circular? So here you can see that 10 is the first node and its previous is pointing to null, and 30 is the last node whose next is pointing to null. So if we replace this null value of 30 to store the address of 10, and 10's previous null value will be suppose replaced by address of 30, then this linked list becomes a circular link. Okay, so there are two null values. One null value is in the next of 30 and one null value is in the previous of 10. So in the previous of 10 we'll store the address of 30, so that the previous node of 10 will be 30 and 30 is next, 30 is next will be 10. Okay, so this is how we can make a linked list circular one. So this doubly linked list will be become circular link. So how to do that? So we'll see now how to make this circular. So actually this linked list is circular right from the head itself. So when we create the head, it should be circular. So here in the create function, when we create the head, what is head's next? Head's next is null. Head's previous is also null. So here you can make it circular by writing that head's arrow next will have the address of head, or you can say head's next will point to the head, or head previous, head arrow previous will also point to head. So head's next address will be head. Head previous is also pointing to head. So it is like 10. 10's next is also 10, as it is circularly connecting to 10, and 10's previous is also 10, like that. Now we have to make some changes in case of display. So what changes are expected in case of display? Basically this null will be removed. We won't have now null one, but we will have the head, because the head's previous is not null now, it will be head only, and its next will also be head. So we'll do that change here, and then we'll have this next will also be head, like that. So after this condition should be changed. So this condition should not be like temp is not equal to null, because now there is never a null value will encounter. Why? Because 10 has a next whose address is 10 only, and 10's previous is also 10. So there is not a null value. So here instead of using this while loop, we have to use a do loop, and uh, we use a do here, so that this do, and it will end with while. So while temp is not equal to. So initially it is head while temp is not equal to head. So if there is a single node and we are starting from head, we will display the data initially using do loop. We will display the data of head, and then we'll go to the next node. Now if the next node is not there, there is address of head only in the next address part. So we'll stop because temp becomes equal to head, and we'll display head only. Right? Now we'll give command to this insert function calling. We'll see insert letter of the doubly circular linked list. I will give comment here like slash star and star slash. So this is the multi-line comment we are giving here in the C. Right? Now we will run So let's see, first value is 10. So we will allocate memory for new node. We will assign data as 10. Then that initially the next address is null, previous address is null, and we check if head is null, then we make head equal to new node, and head's next is head, and head's previous is also head. So it will look like head's previous is pointing to head, head's next is also pointing to head. So this is a circular link. This is a circular link. If I display it number of times, I will able to again come back to 10 on. Okay, so that is also possible. But what we will do, we will insert some nodes. We will make add them into circular link list, and then we'll display. Like in case of insert function, here we are inserting new nodes, right? So now there is no null value anywhere because the last node says next is head, and previous, that is head's previous is also last. There is no null value. You see, whenever we append new node, so its next is like the last node's next is new node. Okay, new node's previous is temp, and new node's next, new node arrow next is equal to head. So see, whenever we change the last node, we'll change the address of that last node's next to point to the head, so that the linked list will always be circular. Okay, like suppose we have 10, so its next has the address of head. Similarly, after 10, if I insert 20, so it should also has the next address pointing to head. So after 10, there is a 20. After 20, there is again 10, like this. So that is why new node's next is head. So initially we reach to the last node. After last node, we append a new node, and then new node's next is head, like that. So we'll do this. We have done these changes, and now we'll uh, remove that insert comment. So now we will insert new nodes in a doubly circular linked list. So now we will run, and then we'll have 10 value, and see, there is a circular linked list because 10's previous is head, 10's next is head, and now we'll have 20. After 20, we are not getting any output, so there is some logical error. So what is that logical error? After 20, the insert function have been called, insert nodes, and then display DLL, right? So in the insert function, we have to check what is the error. So say tmp equal to head, while, oh, see, how we are reaching to the last node. How we are reaching to the last node, because tmp's next is not equal to null. And in case of circular linked list, there is never a null encountered. Never, there is no pointer like previous or next as a null value. So there is a problem here. So here we should write what, while temp's next is not equal to head. Okay, so we need to the last node whose next is pointing to head. So that is the last node. The node whose next is pointing to head is the last node. So for that, I have to use do here also, because when I say temp equal to head, and while temp's next is not equal to head, so that is again, that may like create a problem. Suppose we are starting from head, and then we say that temp's next is not equal to head. So if there is a single node, so it will be like it equal to head. If there are two nodes, then yeah. So I think it will work. So let us try to run. So suppose we have 10, then after 10 we have 20, and okay, it's working. See, So 10 has a previous pointer which is pointing to, it should point to 20, right? So it is pointing to the last node, right? And that is 20 now. And 20 is next is pointing to head. Okay. So 10 will point to the last node, and 10's previous is last node, 10's next is second node. And second node's next is pointing to head. Similarly, if I'll have 30 here, see, now 20's next is not head. Now 20's next is 30, and 30's next is head, right? So we have 10's next 20, 20's next 30, and 30's next is head. Initially, we have only 10. At that time, 10's previous is head, 10's next is head. Then when we have inserted 20, 10's next was 20, and 20's next is head, and 10's previous is 20. Okay. Now we have 10's next as 30, sorry, 20, 20's next as 30, and 30's next as head. So the last node's next has the address of head, and first node, that is 10, has the address of last node, that is 30. Okay. So this is a circular link. I hope you understood this circular link list. We'll revise once more. See, we'll revise a complete program now. So we have this header files. We have a class DLL node, integer data, DLL node. Two pointers are there. So pointer next, pointer previous. There is a single data part and 2 pointers. So it represents the node structure for Doubly. After this, we have this functions like create DLL, insert nodes, and display DLL. Now create DLL will allocate new address to the new node, and then that address will be assigned to head, and that head's address is returned from the function. Insert node will insert new nodes in the W linked list, and display will display the W. Now these new nodes are inserted by appending at the end of the last node. Now, this is how we create a head node by allocating memory using new, assigning the data, initializing pointers to null. Then if head is equal to null, head equal to new node, and as it is a circular linked list, so first node's last is first node, and previous is also first node. Then we return the head from. After that, we have a display function. So we use a do while loop here because we start from head and we cannot like say while temp is not equal to head. So we say temp equal to head, then we display the data of head, and then we go to the next node and then we check whether temp is not equal to head. So this is a display function, and then we have insert nodes where we again allocate memory for new node. We assign data, we say next and previous as well, and then we go to the last node using this temp equal to head, and while temp's next is not equal to head. So the node whose next has the address of first node, that is head, is the last node. So go to that last node, and then last node's next is new node, and then new node's previous is that last node, and new node's next is head, which is the first node, to make it circular one. So this is how we create insert nodes in W circular linked list, and then we create object of class, then we create a pointer of this class, and then we initialize that pointer which is head equal to null, and then we use that head inside a create DLL to assign address of new node as head, and then we return that address and catch it inside head. So head always becomes the first node of the linked list, and then we have displayed it using object d1.display DLL by passing the head, because display will be always from head or first node, and then we are inserting two nodes by calling insert node functions and display functions. So this is all about this. We can again try to run it once. So see, we have a first node here. We can also like say now it's a doubly circular linked list, right? So we can change this message. It's a doubly circular link, right? So now the message will be changed. C++ program for doubly circular linked list, and now we are creating this doubly circular. So here also we need to change the message as it's a doubly circular linked list now. Similarly here displaying doubly circular linked list, and here also doubly circular. And now we will run. So program for doubly circular. We have a first node as 10, then we have a second node as 20, who has the next as pointing to head, and then we have 30. So 30 is the last node who has the address of first node, and first node is 10 who has the address of last node, that is 30. This is all about doubly circular linked list. I hope you have understood the contents of doubly linked list and circular linked list, which is the doubly circular linked list. If you have any doubts, you can ask in the chat.
Sir, can you show the insert node for doubly linked list one more time?
Display node for
Doubly linked list. Insert node.
insert node for doubly or doubly circular.
Circular.
Doubly. So see, this is display function. So in case of doubly circular, we have like initially we have a first node head. So heads next in case of doubly linked list will have null value. In case of uh, doubly linked list, previous also has a null value. So we can write while like temp equal to head and while temp is not equal to null, because we display the data of temp's arrow data and then we say temp equal to temp arrow next. But in case of doubly circular linked list, there is no null value, neither in the previous pointer nor in the next pointer. So we have to start from head, that is compulsory, because head is the first node. And after starting from the head, we cannot immediately say temp is not equal to head, because either neither I say temp not equal to null, because null value is not there, because the first node, even if there is a single node, its next is pointing to head, not null. So if I'm starting from temp equal to head, I cannot say while temp is not equal to head, because I will stop there only. I cannot able to display the first node even. So if I have the linked list, doubly circular linked list, where there is the first node pointing to second, second to third, and third is pointing to head again. So how I can display? I can start from head, like I will display 10, then I will go to 20, I will display 20, then I will go to 30, I will display 30, and then I will check whether 30 is next is pointing to head, because if temp has a address of head, after saying temp equal to temps next at node 30, so that loop will break while temp is not equal to head, because temp becomes equal to head. And why we have do while? Because if there is a single node, we cannot even display temp, because we are starting from head and we are writing temp is not equal to head. So we cannot even display head also, right? So we have to shift from head to the next node, and then we will check now temp is not equal to head. Understood?
Yes, sir.
Okay.
Sir, can you show the code for insert node? I'm getting some error in that.
Okay. I'll share the program.
Okay, sir.
You can try it at home.